The Fish and Wildlife Service has been using a combination of avian radar systems, acoustic ultrasonic monitors, historic observations, which we are having digitized, and current bird observations to document migration along the shorelines of the Great Lakes. And we started this back in the spring of 2011. Now, the impetus for this study has been the potential development of wind facilities along the Great Lakes. But the data can also be used to evaluate communication towers, tall buildings, or any urban development along these areas, or to decide whether habitat should be protected or enhanced along the shorelines. The presentation today will focus on what we have learned from avian radar systems and ultrasonic monitors. We found that avian radar systems are highly effective in monitoring migration patterns, particularly for nocturnal migrants such as passerines and bats. It collects data on the diurnal migrants also, but the local traffic of birds is such that it's hard to separate it out. So we're capturing it. It's not always easy to see, especially along the shorelines. You've got a lot of waterfowl and shorebirds moving up and down that shoreline also. So we're going to focus on nocturnal migrants today. We think radar is the best tool available for this type of work, but it's not without its limitations, and I'll point some of that out today so that you can become more familiar with studies or the limitations that may be in studies when someone comes to you and says, we've done radar on this area and this is what we found. A little bit of insight helps to understand better what they may have missed. This information is largely preliminary. Our data collection is automated. Our radars run 24/7 when we're out in the field, and our acoustic ultrasonic monitors are operating from dusk to dawn. Unfortunately, our data analysis and our report writing doesn't operate on that same schedule. So we're running several years behind. Our first report, we hope will be out last month, but we didn't make it, so we keep trying. And we're making adjustments to try and catch up. I'm going to present information today, much of which has been reported in the literature, and those of you that are avian biologists are going to come away and say, I knew all of this, there's nothing new here. And to a large extent that may be true. The difference is we're bringing it together in a cohesive pattern. You're going to get to see it, not just hear it. And it's the type of information that too often developers and their consultants forget to mention. So yes, avian biologists know it, but the general public doesn't always know it. The people that are making the decisions don't always know it. One theme of this presentation is to explain how our research may prove insight into reviewing similar studies that are being done for proposed construction. The second theme is the usage and apparent value of these shoreline areas to migrants. Sorry, I should have flipped that slide. This is a map of where we've had our avian radar units over the past 5 seasons where we currently are. So we started out here in Wisconsin with 2 units very close together. We've traveled to Michigan, different parts of Lake Michigan, Lake Huron. Right now we're on Lake Ontario. And the first 2 seasons, we would do an entire season so we could truly understand what migration looked like from start to end and get a better idea of that. Since then, we've been trying to split and take 2 locations per unit per season, because now that we know what a full season of migration looks like, we can have more confidence that once we're seeing it and documenting it, we can move on and catch another one, fill in the pieces. This is where we've had acoustic monitors located around the Great Lakes. As you'll notice, we have a lot more locations here. Acoustic monitors are a lot less expensive than radar units, so we can afford to have more. We have a partnership with USGS and the University of Minnesota. They have loaned us some. We've had as many as 34 units out per season in some cases. And this is a map that our GIS specialist has developed. He takes it from FAA data, and it shows proposed and existing towers. You need to get permits if you're going to build towers over 200 feet from the FAA. So this is one way that we have of monitoring where there's potential wind projects around the Great Lakes. And this is one of the items that we use in prioritizing where we go. So we look at what's coming into the FAA. We look at the wind resource maps to understand where a wind developer may potentially want to develop. We look at where there's population centers, because they're not going to develop if they don't have a relatively nearby place to sell the electricity. And then in some cases, we have to make some political adjustments also. The other thing is, especially in the beginning, we needed to look at logistics. We kept our radar units fairly close together, and we still try to, so that staff from one can support the staff from another. At first, we wanted to keep fairly close to where we were based, but now we are comfortable going as far away as Lake Ontario. This is a photograph of the acoustic monitors that we're using. This is the bird microphone here. We place it about 6 meters in the air. There's a square plexiglass to help protect the microphone from noise such as insects or other noise coming up from the ground. So we try to get more bird noises. The bat microphone, or the ultrasonic microphone, is just located next to the monitor. We aren't worried about picking up ultrasonic extraneous calls, so that hasn't been as much of a problem. And I want to show you a short video. In the fall of 2011, we had acoustic monitors where all the X's are on both sides of Lake Michigan. And this is going to show you the number of bat passes that occurred on a nightly basis. And you're going to tell the numbers by the size of the dots that come popping up here. And you'll see the dates changing, so you can kind of keep track of what's going on and when it's happening. And this is a part where I'm going to ask Sumner to turn off the... And my apologies, you missed a great video.
Jeff, could you explain what we should have seen?
Yeah.
Yeah, in case we never do get that video up, or get this thing to work. What you would have seen is, especially on the Wisconsin shoreline, you've seen a lot of dots popping up, showing high bat activity on different nights, sometimes at different locations on the same nights. And in Door County, you'd have seen circles pop up that would have covered all of Green Bay. I mean, huge numbers up there. And the one thing I do want to tell you is, I mean, it would have looked impressive. The other thing is that we've been working with University of Minnesota, a doctoral student there by the name of Kevin Heist. He's the one that helped set us up with the acoustic monitors in the first place. He's also done our initial data cleaning, where he takes all the extraneous noise and just sends us the actual calls. Kevin's research is to put up acoustic monitors at wind facilities to compare bat activity with the number of fatalities that they're finding at these wind facilities. So he's got acoustic monitors scattered throughout the Midwest, from Minnesota down to Texas. And what Kevin has said is there is no place that his acoustic monitors are picking up the numbers of bat passes that we're seeing here along the Great Lakes shoreline. So it's not like it looks like a lot of calls. According to what we're seeing, there are a lot of activity here. So that's what you missed.
Is that the same for the east shoreline and the west shoreline, or is the Wisconsin shoreline much greater?
The Wisconsin shoreline, at least for this year in the fall, had much larger numbers than what we were seeing on the Michigan shoreline for whatever reason. The one other thing, go back 1, 2. In Wisconsin here, we are still continuing to run a series of transects. We've got 3 areas where we've got transects with acoustic monitor near shore, and then we work progressively inland, trying to see if we can get a differential or not between the amount of calls. Now, we thought initially that would be an easy thing to determine. It is not. It's very difficult, but we're still working on it.
When you're recording that high bat activity, are you, just make sure I understand what you're saying, are you receiving that as local activity or movement of birds through the area?
We pick up a bat call, and the machine's sophisticated, so it's set that once it starts picking up a call, it'll record that as a single bat pass until there's a certain period of time between calls, because the bat will keep sending out signals, so it's supposedly taking a call. Now, are there local bats there or migrants going through? Probably both. You know, it's hard to separate this out. But when you start looking at the numbers, and you see huge numbers one night, and then you don't see anything for a period of time, and then another huge number, I would assume that part of that's because of migrants going through, that the bats are feeding, the local bats are feeding relatively consistently. Now, they may move to other areas and not be picked up by the monitor, but I think a lot of those large pulses, and you're going to keep seeing pulses throughout this talk, is migration occurring. One of the other things that we're using the acoustic monitors for is to correlate between weather patterns or weather parameters and when we see bat activity. We have 2 acoustic monitors that travel with each one of the radar units, so they're located in the same vicinity. Within the radar unit, there is a weather station. So we can take the weather that we're finding right at the radar unit, correlate it with the acoustic monitors and say when are the bats active based on temperature and on wind speed. And the practical application is we have a number of wind facilities that are coming to us and say, we don't have any listed bats, which is primarily the Indiana bat, at our wind facility during the summer because we don't have any habitat. Indiana bats require forested habitat, so we don't have any Indiana bats here. But in the fall, they do come through our area. So rather than take the time and money to get an incidental take permit, which would allow us to legally take a listed species, we'll just operate under those conditions such that you, the service, don't believe we're likely to take any bats, including the listed bats. So we've taken this and said, okay, under what temperature, under what wind speeds, are we not likely to see bat activity at all? We've combined all the bats. We're not separating this out into, certainly not into Indiana bats, but we're taking all the bats. And that's why you see percentiles here is fairly high. We start at 90 and we work down to 99.9, because if we're going to go under challenge into court and say we're confident that they aren't taking bats, we're going to have to be somewhere in this area. So this is from the fall. We were on the west side of Lake Huron, the east side of Lake Michigan. When we get down into 99.9, you can see that at about 6.9 meters per second, we aren't seeing bat activity any higher. So we're starting to think this may be at least a good cut to initially draw the line. Temperature shows more variation between the two sites. So somewhere between 6.8 and 6 degrees centigrade. When it gets colder than that, we aren't seeing much bat activity. Now this was our first effort at this last fall. Since then, our staff has been taking a look at combining these two, and they're finding that there is an interaction, so that when temperatures get warmer, bats will be active in higher wind speeds, which makes some sense, and as it gets colder, they're active in lower wind speeds. So combining these two will give us better than just drawing a straight line. We get more information. We've also...
I didn't mean to interrupt.
Oh.
Finish your thought.
Okay. We also have found that if we just take a look at drawing the line with one parameter, we don't see much of a separation between the high frequency and the low frequency bats. But when we separate it and use a model with temperature and wind combined, we are seeing a difference that the low frequency bats are not using as wide a range of temperature and wind speed as what the high frequency bats are. So we think that that's probably going to be the next effort that we come out with, is starting to look at these two together. And that may not be the end of the parameters, but that's where we're starting.
So I studied hawk migration for my graduate work, and one of the big factors is wind direction, especially along these water bodies, which are barriers in many cases. But it seems like that'd be interesting to throw that in as a variable too.
We've taken it and looked at some of the
Yeah.
stuff initially, and some of it doesn't pop out as well as you want it to. But
Yeah.
and we also know that within our data, we probably have a number of theses and dissertations that what we don't have time to look at, we can give to somebody else and have them really study this and work some of this stuff out. I'm going to switch now and talk about avian radar systems for much of the rest of this presentation. This is a photograph of one of the two units that the service has bought. There's a wide variation of what people are using right now for avian radar to try and study bird and bat migration. This is one of the more common types of design in that you've got two antennae, the horizontal up here and the vertical down here. And each one of them records a different type of data. The two combined give you a more complete picture. This schematic here shows you this is what the horizontal is, that field that it's sampling. That goes out about 2 nautical miles. And as you can see, there's a limit to how high up it will go. The vertical takes a more narrow slice out of the atmosphere and will go up usually as high as what you're likely to find targets several kilometers up. And is a little bit more precise in trying to give us quantitative counts of the number of targets moving through when things are working right. And I'll get into some of that. Typically, we orient the unit so that the vertical antenna is perpendicular to our anticipated line of travel, so that the targets are moving through the beam and we get a nice consistent count from them. Unfortunately, the targets haven't always read the same books that we have, so when you get on some of the east-west shorelines of lakes, they aren't always moving the direction that you anticipate. This spring, we had our crew out there moving that radar unit around several times to try and get it oriented in the right direction. Doesn't make you popular when you ask them to do that. A couple other things. I spent a year in hell trying to get these things purchased, going through the bidding process and bid challenges and trying to spec them out. And it was worth it, because what we were seeking was a very sophisticated unit that was as turnkey ready as we could possibly get it, so that we could start collecting data, not spending our time trying to build a unit, which a number of people have done. They've built their own. So we're looking for a unit that automated data collection by including the tracking automatically, the processing and storage of the data. We're looking at a unit that had successfully field tested the integration of the hardware, the software, and the electronics, and would offer us continuing factory support as we ran into problems, and we keep running into problems. One of the advantages of using an automatic tracking system is that you eliminate both buyer observer bias and fatigue, and I think you'll see in the next few slides what fatigue would look like if you're trying to count this by hand. And one of the concerns we've got is if you have studies coming in that are using avian radar, there isn't any consistency in what's being used out there. So it's very, very hard to compare one study to another or to know what the strengths or weaknesses of that particular design are. So if somebody was submitting a study to us, I won't speak for others, we would be looking for them to use a radar system that had many of these same features, that had something that was relatively standardized so that you'd understand what the system did and what it didn't. This is the inside of the unit. There are two computer screens, so you can watch what's going on both antennas, both either on the raw data or on the process data, which makes it a little bit easier to see. There's 5 computers, 2 of which run each of the antenna, collecting the raw data, processing it, and then a 5th computer stores it in a SQL database. These are some of the people that are working to put all this together. Our field crew, except that 2 of them now are being kept back in the office. We're only allowed, we've cut our field crew in half. Getting back to this, we collect data 24/7. Well, we're trying to process all year round too, not just between the active seasons, so we've made some adjustments. Eric is the guy that produces our FAA maps and does some of our GIS work for us. And David's the man that tried to run from one shoreline on Michigan to the other while I was frantically trying to hire the rest of the crew. So between us, we are barely keeping up with all the information that's coming in. One of the things that the unit does is it will produce schematic graphs like you see here of what is happening throughout the night, and it will produce these either on a 15-minute or on a 1-hour basis. We're on the east shore of Lake Michigan right now. This is in the fall. This little color wheel, this is a horizontal radar. This little color wheel tells us the direction of travel, which is the main thing, piece of information we're getting out of the horizontal antenna, along with getting a bird's eye view of what's really going on. It makes it much easier to understand. This is 3/4 mile from the shoreline of Lake Michigan. The lake shore is right through here. 1-hour graphic here. As you can see from the warm colors, all of our traffic is moving in a southerly direction, which is what we'd expect in the fall. This is a good example of why trying to count these targets using a human, I would think by morning they'd be gone. You really can't do this. But the machine keeps up fairly well with these large numbers. The vertical antenna is used to give us altitude. I don't know if you can see these lines, but every other line that has a number on it is 1,000 feet in altitude. So here we're working at relatively low altitudes, and you can see that the density of the targets decreases as we go higher in altitude. We also look for consistency between those 2 antennae. If we don't show high numbers in both of them, then something is going on that's a little bit strange. One antenna is not working, the targets are not moving in the direction we intended them to do. In a couple cases, we had double counts being targets being put into our file base, and suddenly things weren't right. So it's a nice check on each other to have those 2 antennae. It's also important that if people are going to do radar studies, that they recognize bad information. On the left is the vertical antenna. This is a rain event, and we can tell that because we're not getting uniform direction. They're not flying in straight lines. It's going all over. It's simply tracking raindrops right here. The other clue is we have just as many tracks up here as we do down low, and that's not going to happen with real targets on a vertical. This is from an S-band, which is what our units use. It has a longer pulse, about 10 centimeters on the radar pulse. It does not pick up rain as easily as the shorter pulse X-band does. It doesn't pick up insects. But when we go through and we do this, at least on an hourly basis, usually on 15-minute basis, we look for this, we toss out that data. We also have editors that can, if it's not too bad, we can take out the bad information and leave the real information behind. Over here on the right is an X-band vertical radar. This first year in Wisconsin, the manufacturer failed to deliver on time. So after some talking with him, he agreed to bring in some loaner units, so at least we didn't miss our entire season. But they were older units, they used X-band radar. It's a shorter pulse, it finds smaller targets, but some of the targets it finds, as you see in this photograph here, is insects. Something our S-bands don't do anymore. But when you see something like this, you either have to clean it up or toss out again. That's not real birds and bats moving through. Okay, let's take a look at Wisconsin. Spring of 2011. We located one radar unit 3/4 nautical mile inland from the shore. We put the other one 3 nautical miles inland from the shore. Our hope was to see if we could see any differential between the near shore and farther inland. This is Point Beach State Park here, 2 rivers down here. Spring of 2011 was a lot like spring of 2013. April 23rd, and we're trying to dig our way in here so we can put this radar unit about 1/4 mile off the road. We found that 2 4x4s chained together wouldn't move that thing. So we ended up asking the landowner to bring one of his smaller tractors down, and he placed that unit for us. And want to have a special thanks for Mark Funk, who's on the tractor. He had the inland site, and Clarence Glazer owned the land for the nearshore site. And it's been amazing that we can go almost anywhere along the Great Lakes shoreline, pick out a site that will work for our radar units, approach the landowner, and be surprised at how willing they are to accommodate us and let us put our units out there. This is a graph of the season then for the spring of 2011. This is the near shore site, and the blue line is the horizontal antenna, and it will collect more targets if things are working right than what the vertical does, because it samples in a wider area. And then the red line is the vertical antenna. These are the dates from April 20th when we first turned it on till about June 20th or 15th when we finally turned it off. Each one of these bars is midnight in time. It's a 24-hour series. And you'll see several things here. We're not going to study this too much, but one, we see pulses of migration, and then we have quiet periods in between. And I'll keep stressing this throughout the talk. Migration occurs in pulses. That's how it happens, and if you're not sampling to accommodate that, you're going to miss it. The other thing is, notice how these peaks line up on midnight? Very consistent. For nocturnal migrants, migration tends to peak at midnight, increase as dusk starts, and then decrease towards dawn, and we find that wherever we go.
So are these data 24-hour or are these data just night?
No, this is 24 hours, but the low parts here, the middle, halfway between each one of these lines is the daytime, and we'll zoom in, you can see daytime a little bit better in a while.
Okay. You had commented at the beginning that you were going to focus just on the night. So is this collecting the day movements?
This is collecting the day. We don't
Okay.
turn off the radar.
Okay.
And you'll get a better idea what's going on in the day. I'll keep showing you more information. What we can't do easily is separate out the local traffic that occurs in the day from the daytime migrants that are passing through. Okay, May 28th, 12 noon, near shore site. You're seeing some activity here. There's some northerly movement along the shoreline here. And again, this could be some diurnal migrants, quite likely waterfowl and shorebirds moving up and down the shoreline here. Notice the vertical isn't picking up much traffic at all. We go to 1900 hours, there's still some northerly movement and traffic. Vertical still not picking up too much. It's going to be consistent. We go to 2000 hours, and here's the bloom migration starting. And notice the vertical, we probably have some false targets in here, but notice that the verticals come alive here. Some of these blank areas, that doesn't mean that the targets aren't moving through there. It means we've got ground clutter and the radar is not picking it up very well. So here's our shoreline. Notice we have a lot of targets out here over the open water. 2200.
On the vertical radar, I'm assuming that that's a line perpendicular to the shoreline?
Yeah.
Okay.
Yeah. Like I say,
And about where is the shoreline on the vertical radar plot?
you won't see the shoreline on the vertical radar. Well, I take that back. This is 3/4 nautical mile in. Shoreline's probably about here. 2200 hours, midnight, we're still seeing migration continuing. 2 o'clock, it's continuing. By 5 o'clock, as we approach dawn, it's greatly decreased. Numbers are going down. Vertical's not picking up much anymore. And now we'll go to the inland site and take a look at that same night. Noon, again, some traffic, but these different colors are telling us this traffic isn't moving in a uniform direction. It's flying around. There's a large wetland located right over here, actually a flooded field, and we're getting a lot of gulls and other birds will come in there, a lot of local traffic going on during the day. So we are picking up some targets here on the vertical. 1900 hours, again, light traffic, a little bit on the vertical. 2000 hours, same phenomena. We're starting to see the targets picking up an awful lot here on the vertical. We had thought that possibly one of the things that might happen is we were about in the position where if some of the targets were going to move on the west side of Green Bay, this might be about where they start to split. So we might see some northwesterly movement. But you notice this movement by the blue color and the light blue color is all moving north and northeast here. So they're still moving north. We don't see any split going around. 2200, we continue with the migration. Midnight, still continuing. 2 o'clock in the morning, continuing. 5 o'clock in the morning, again, that same decrease in numbers, both on the horizontal and on the vertical. And then that's a fairly typical night when one of those big peaks was occurring. And that's the targets doing what we want them to do, is move north in the springtime. But there are nights when they don't do what we expect them to do. And again, this has been reported in the literature, and it's simply something to be aware of, is that not everything's moving north every night. 1900 hours, notice here that based on the colors, we've got more of an east and southeast movement. By 2000 hours, we've got a lot of activity. There's a little bit moving north, but again, an awful lot's moving out to the east or southeast out over the water. By 2100 hours, more of the targets are going in a northerly direction. By 2200, now they're headed some north, but a lot west with that violet color. Continues to 2300 hours into midnight. And then by 4 o'clock, we're seeing strong movement to the southeast again. And that continues to 5 o'clock in the morning. And this is what we call reverse migration. We do see it on the radar from time to time. Certainly been reported in the literature. People have observed it. So there are times whether the migrants are seeing that they're getting beyond themselves, there's still snow up there, they can't find the food, they're coming back down or whatever, the winds are wrong, we aren't sure exactly what's going on. But some nights they aren't really moving, it's more that they're going around. Literature has reported that there are tests that have been detected that migrants will go up, kind of test what the atmosphere is like, see if it's a good night to move or not, and then maybe come back down if it's not. So some nights they aren't going anyplace. May 24th is a very unique night. Notice that we're getting a lot of targets. This is the near shore and the inland side by side, both the horizontal. And notice that we're picking up a lot of targets going west, coming in off the water. This continues as we get later in the night, 2200 hours coming off the water. We don't know what these targets are, but considering that they're going west and they're coming in off the water on a steady basis, the other shore of Lake Michigan is 52 miles away from here. And my best guess is that that's where those targets are coming from. They've left Michigan, are flying across the water, and continuing on inland here. This continues to midnight, still that westerly direction. And that was kind of the end of that. And then May 26th at midnight, nothing happening. Nothing's going on. May 27th, very little activity and no direction to it, again at midnight. May 28th at midnight. This was one of the highest nights that we had. So suddenly everybody's moving north and northeast again. So some nights nothing's going on, and those are those low points that we see on that seasonal graph. And then when the conditions are right, they take off. Yes.
Can you actually do density counts based on those radar readings? So you can-
Yes,
you
yeah.
can- Okay.
And somewhere here in the slide system, I'll talk about that a little bit more.
Okay.
Right now, I want to take you now to the fall and over here to, well, I'll be talking about both of these sites, the east side of Lake Michigan, the west side of Lake Huron, for a few graphs that we already had prepared for another presentation. We're now on the east side of Lake Michigan. It's fall. There's the radar unit. Somewhere under there is the shoreline of Lake Michigan. Strong movement to the south. Strong numbers coming on the vertical. Let me go back here. This is 2 o'clock in the morning. 5 o'clock in the morning, the vertical's not picking up as many targets, and the direction of many of them has changed. They're moving to the southeast, coming in off the water, in towards land. By 6 o'clock in the morning, the vertical's picking up almost nothing. There's not much activity on land, but right along the shoreline, look at the strong number of targets coming in over water. Again, this has been reported in the literature. As dawn approaches, any of the nocturnal migrants that find themselves over water either can keep flying and be subject to predation, or they've got to come into land. And that's what's happening here. That picture is showing you coming into land as day approaches. And what it points out is the importance of having both habitat there for these nighttime migrants to come into, and making sure there aren't obstacles such as communication towers and wind facilities that they have to bypass as they're coming into safety, the only safety they've got.
And these are, since this is radar, we don't know if these are birds or bats.
We don't know.
It's just some
Yep.
collectively.
If we get far enough into our data analysis, we can probably separate out, based on the acoustic monitors, nights when we had more bat calls than bird calls, but we'll never know for sure. And I think there's something like 23 different parameters that are measured on every one of these targets. So speed, reflectivity, and things like that. Eventually, we may be able to tease it out. We've also tried an experimental unit that was last fall that just shoots a radar beam straight up in the air and can get much clearer picture of actually the wing beats. This is something the manufacturer is still developing. So we ran that for a season right next to our other radar unit, but they still don't have the algorithms built that will tell us what it is. So we're still waiting for that information. Yeah.
I don't know if you mentioned it, but for the folks that are as confused about radar as I am, I think what you can say on that left picture is that those birds aren't continuing inland then, they're basically settling right along the lakeshore because your pathway, it doesn't continue to the east.
The pathway, the pathway doesn't continue to the east, so that probably is, and there's two things that could happen. They're probably settling when they get in there. They've been flying for probably much of the night. They're tired, so yeah. And it's daytime, so flying is going to be dangerous for them. So they're probably settling. But they could be coming in low enough that we're not catching them anymore either. Either one is possible. Yeah, if they're flying, once they get down below tree height, we're never going to pick them up. Because most of this has been either forested in here or orchards. So the radar doesn't get the low targets here as well as it does in the open ag areas. But that's probably the best guess is, yeah, they're landing as soon as they get to someplace. Okay. Notice here that we've got a lot of targets. The vertical antenna is not picking them up. Here's the reason. That vertical antenna is oriented perpendicular to the anticipated line of travel, which was north-south. These last targets are moving east-west. Here's the radar beam. It starts out low at the radar, spreads out to be about 1 kilometer wide when we're up at about 3 kilometers. But if the targets are moving parallel to that radar beam, most of them are going to go on either side, and as they get lower, it's harder and harder to get that radar beam. So that's why we're not picking up many targets. That's why it's nice to have both of those antennae, because some nights you say, we're not seeing much. That doesn't mean there's not much going on. It might mean that the targets are simply flying parallel to the direction you thought they were going to fly. And we have to move the entire unit and then readjust it again in order to switch directions. So we're kind of stuck with the direction we set it at. This is important. The other thing is, even if they're flying perpendicular, as you get down lower, our units are set so that they have to hit the same target 4 times before they record it in the database. Obviously, you need at least 2 points to get a track, but they have to record it 4 times. As we get lower, a relatively fast flying target may go through that narrow beam down there and never be picked up and recorded in the database. So what this tells you, and the other thing, and I don't have these graphs with me, is we've had several major rain events. We saw some of that clutter from before. And so we're throwing out the data because all that we're getting is rain. But if we assume that rain is fairly constant from up high down to the ground, then we can look at those patterns and see where our antennae are actually recording well and where they're not. And consistently, as we get into these low altitudes, we're not recording very well. So what that means is we have an inherent bias in this radar and any other radar. Whenever radar sends out a beam, it's going to start out narrow and get wider. There's a bias near the ground. Radar cannot measure right next to itself because the pulse is so intense that it won't pick up the reflectivity yet. So there has to be a certain distance before it records anything. There's also the problem with it simply doesn't record well when that beam is narrow. The point is, there are many radar studies that come in and say, yes, we detected migrants, there's migrants moving through here. But the good news is they aren't flying in the rotor swept area, they're all above there. No, unless you have a correction factor, you don't know what's flying through the rotor swept area. We are working on it and we're starting to develop a factor that improves it. We don't know if we've really got it yet. But uncorrected data, be extremely skeptical of anybody that says, oh, they're not flying in the rotor swept area. They probably haven't adjusted for the inherent bias, and this would be true of any radar. It's going to have a bias as you're in close. That radar beam is still narrow. And then, of course, you have to keep in mind that all migrants are going to go through the rotor swept area twice a night, once as they go up and once as they come back down again.
Question, you had talked about the impact of rain. Does fog, does a lower density moisture also have an impact?
It can. If you're using X-beam antennas, it's much more likely to. On our S-beams, we haven't noticed much of a problem. And usually, if we are having rain that's causing us a problem, it'll be 15 minutes to maybe an hour. Only when there's heavy downpours, that really gives us a problem on the S-beam antennas. And then we'll throw out that data and use the rest of it.
And have you been seeing anything related to Ken's question about the altitude and cloud ceiling? Or are you?
We have a hard time getting that. I mean, sometimes we will see rain events up high and targets down low, and you can actually see it, but it's not easy to get that. And it almost is going to take a special search to say, can we show the density or the altitudes going down as both the wind and the ceilings change? Weather stations, unfortunately, don't measure visibility, so that's a difficult one for us to get. This is that same type of graph, but now from the fall on the west side of Lake Huron. And because our season's pretty long in this case, we have a lot of peaks. Here's our midnight lines again, horizontal and vertical. But we'll zoom in here and take it closer. The one thing I do want to point out is, again, we have pulses and low periods. Again, migration occurs in pulses. This is top graph is early in the season. Here's our horizontal. Notice how it's lining up with those midnight lines again. And our vertical showing peaks at roughly the same times. Point here is, early in the season, we're seeing peaks on midnight, some nights not, but we keep seeing peaks at midnight. And that's migration occurring. And then as we get late into the season, from late October to early November, two things happen. We don't see any pulses on that vertical anymore, and that's because the targets that are going through are no longer moving in a unidirection. These are local targets. This is, again, ag area. And notice that we aren't seeing the peaks at midnight anymore. We're seeing them during the daytime. This is dawn, this is evening. Dawn and evening. This is simply local traffic going through. So, again, by watching it throughout the season, by having the two antennae, and by looking at what's occurring both in day and night, you can start seeing the shift in what's going on. Yes, there's still targets. These would all be birds, of course, during the daytime, moving around, but these aren't the migrants moving through anymore. West side of Lake Huron, let's say that I'm a developer, or maybe I'm a federal biologist, but I've been sequestered, so my my funding has been cut back. So I'm going to sample with radar, but I can't afford to run this every day. So what I'll do is sample for a month, but I'll just sample once a week. And this is what I find on my vertical antenna here as I sample for a week for a full month. And we say, oh, there's not much migration going on here. We got one pulse over here, but for the most part, this seems like a pretty good place to build because not much is going on. But we weren't sequestered and we weren't trying to save money, so we did sample through the entire period. So let's see what we missed. These ellipses show where we would have sampled, and here's what we were missing. Getting back to that same point again, migration occurs in pulses, and if you sample intermittently, whether it's with radar or mesh netting or visual observations, you're going to miss a lot of the migration that's going on. You need to be sampling consistently. If they're not, don't believe that study very much. This gets back to an earlier question. This is a summary of our vertical antenna on 1 kilometer front. So this is where we just take a kilometer on the vertical antenna wide, and we take it per hour. And this is a summary for the entire season back in Wisconsin here at inland site. So here's midnight, and you can see number of total targets that we saw. It decreases as we get to daylight, stays down, a little bit of activity here in the afternoon, and then rises again as we get to the evening. So yes, we are getting quantitative data, and we can start seeing patterns that much more happening at night than is happening during the day. If this wasn't an agricultural area, this would be much lower in here. Not because there may be less activity during the day, but the radar will not pick up birds flying around in the forest. So we can pick them up over ag land, we won't pick them up in the trees. They've got to get up above that height. This is from the east side of Lake Michigan. The red line is the radar, the vertical antenna, and you can see the peaks of the migration. The blue line is one of the acoustic monitors that was next to the radar, measuring bat calls. And you can see there's fairly good agreement between when we're seeing activity on the acoustic monitor and when we're seeing activity on the radar. Now there's times when there's not. It's possible that acoustic monitor wasn't turned on here, or else we were getting mostly birds coming through here, and there's other places we're not seeing much, and these are probably mostly birds going through. But we are getting a relatively good correlation here. Last graphic. This is from, the top graph is on Lake Huron, the bottom graph, Lake Michigan. The blue bars are nighttime movement, the gold bars are daytime movement. And what the rectangles are trying to show is that even though we've got units on opposite sides of the state of Michigan, during these first two sets, we are starting to see some similarity of when pulses are occurring on both sides of the state. So whatever factors are influencing it are probably relatively large, like barometric pressure or general wind direction, something like that. And then as we get to the end of the season, you notice that it's tapering off on both sides of the state. So while there can be local factors influencing it, it does seem that much of what's determining when migration occurs are large weather events. So in summary, we think radar is useful for documenting migration, particularly for nocturnal migrants. Migration, according to what we found, is indicated by three factors: uniformity of direction, high numbers, and a general increase and decrease of targets over the course of the night. We would recommend that if someone's doing surveys for pre-construction studies, that they do both the entire spring and entire fall seasons unless they have other data available to them. And one reason is, if you're a developer, you're trying to prove a negative. Migration doesn't ever occur here. And that takes more information than trying to prove the positive. Yes, we see migration. We don't have to keep seeing it. Multiple years may be necessary because it's not going to occur the same necessarily every year. Migration occurs in pulses. I've been saying this throughout the talk. So sampling has to be continuous for however long sampling occurs. If it isn't, you're likely to miss what's really going on out there. Sampling 24 hours a day is useful to understand the differences between the local traffic that's going on and to see the migrants passing through. However, your data absolutely must be analyzed between day and night. If you don't, you're going to confound everything that's going on because there's vast differences between the two. And we oftentimes will take it down to 1 hour, 15-minute blocks just to clean up the data. We found that the comparisons between the vertical and horizontal antenna are very useful so that we're sure that both antennas are giving us true information. If they don't have the same ratio that we're used to seeing, something's wrong on one of them. Measurements of altitude currently have inherent bias in them, and unless there's a correction factor that's been validated, be very careful of looking at that lower altitude area. The rest of it I think is very good, but that low altitude has got a bias in it. It's not collecting it well. Okay, my final points. We believe that the lakeshore is an important migration corridor, whether you're talking about the west side of Lake Michigan or most of the other lakeshore along the Great Lakes. We base this on our ultrasonic monitors, our Avian radar, studies that have been done with NexRad radar, and the historic observations. We think the evidence is getting to be pretty conclusive. Habitat along the lakeshore is important, both as stopover sites for the migrants that are passing through, and as a refuge for the migrants that come off the water at dawn, and you have to see that when dawn occurs, they've got to get to land or they're dead. Our purpose in conducting these studies is to assist our field offices, the DNRs, and on those states that are fortunate to have a permitting process, the Public Service Commission or whatever entity controls that. As I said, we're collecting data faster than we can analyze it, so we don't have reports out yet. We are trying our best to catch up with ourselves and get those out, but we will give you whatever assistance we can for whatever projects you've got. We can bring in the data we do have available to us right now. And finally, we get to the commercial. Funding for this study has been provided by the Great Lakes Restoration Initiative. This is a special initiative that's giving money out for a number of research studies and other activities along the Great Lakes trying to improve it. The service has gotten a fair amount of that money. This is the only study that's looking at wind and wildlife. We couldn't have done it without this funding, and it will end the day that this funding stops because the service can't pay for this with its own existing budget. So that's what's allowing this to happen. And I can answer easy questions.
So, one of the applications of this work is to help site facilities that will be there for many years, right? But your study sites are, moving up and down, kind of get a general picture of what's going on. So how would you apply, any one point's worth of data over time? Can you conclude that that site is good year after year for birds or migrants or not?
Where we've got relatively straight shoreline like this, I'm willing, and we've got acoustic monitors up and down here, I'm willing to say that what we were seeing here probably applies for most of this shoreline. I'll do the same thing over here for at least this stretch of shoreline and say we're seeing migration come through here. While we did see what may have been some migrants coming across the lake, I'm thinking that most of them aren't going to do a sharp right turn in either direction. They're going to keep moving down here. So I'll say migration's occurring here. If you want to develop in this area, please go out and prove me wrong. You do the same studies on your site and show that there are no migrants coming through there, and then we'll take a look at that. But until you can do that, that's what we'll start with as a starting basis.
And so what have you seen, because that's the million-dollar question for a lot of these developments, inland versus how far outshore, does it contract, does it shift, how variable do you?
That's one of the things, that was probably one of the second questions we want to do is say, okay, if we can see it along the shoreline, how far inland before it starts to go off? And it's proven more difficult than what we had anticipated. In the case of Wisconsin, we're about 3/4 of a nautical mile inland, and we see out 2 nautical miles. So we can say with confidence that those 3 miles near shore, we're seeing migration occurring if it's occurring. With the second site, then we can see a little bit farther inland. In this case, it was wider than I would have anticipated. And the first look at the data, and again, our spring data in 2011 wasn't great data. We did have problems. The 2 units weren't identical. We're probably not going to find a difference on the inland site to the shore site. So we were hoping we would. We haven't seen that yet.
What do you mean when you say not find a difference, that they're similar, or that?
We're not, if we saw half as many or a third as many targets inland as we did in shore, then we'd say someplace in here there's a drop-off line. We aren't seeing that. It seems to be, we can't see a difference between those 2 sites yet. Now, we're trying a couple things. We've added long-range radar into one of our units, so it can look out 6 to 9 nautical miles and see if we can start seeing a difference with that. The other thing that we're doing over here in Lake Ontario, we've got a unit here on the shoreline. We're going to move it further inland as a control to make sure that we aren't just seeing fewer targets because there's less migration. We've picked sites that Jeff Bueller, who's been using NexRad radar to try and look for stopover habitat, can use the NexRad radar that's here at Buffalo. He can see both of these sites are about equal distance from the NexRad radar and use that as our control so that if we do see a decrease, he can tell us whether or not the number of targets he's seeing on the lakeshore has really decreased or not. So we're trying that as another example of ways to try and get that measurement. But it's going to take a while to get that width there and to find out how much that varies back and forth. I'm not sure that I'll still be here when we get those answers. So it's more difficult than what we had anticipated. Right now what we're doing is saying we're at least going to protect those first 3 miles of shoreline that we know there's migration occurring. And then if I was going to draw maps, which we hope to do, I would probably go out at least another 3 miles with kind of a yellow line and say, we aren't sure what's going on here, but you should be very cautious. You should be doing studies before you site in this area.